Hey everyone, I thought we'd maybe do one more example from our problem sheet. So I thought I'd pick out number 15. It's the spotlight is shining on the ground and it's 10 meters away from the wall. You've got this little guy at it's 6'6", I guess 2 meters and then very short, 2 meter tall guy walking away from the light. And he's walking at a constant speed, 1.2 meters per second. And the question is, how fast is the shadow changing when this distance here is 3 meters? Now we leave these as x and y here because as a person's walking, his height won't change, but he'll change in terms of x might be 1, y is 9, 2 and 8, that kind of thing. And then you want to figure it out what happens when he's 3 meters from the wall or 7 meters from the light. So that's the problem we're trying to solve. So to set this problem up, it's just like the water in the cone problem. We have a triangle that we talk about being proportional, being similar. So I set my similarities up so that I'm talking about small triangle, horizontal distance x, vertical distance 2, horizontal x, vertical 2. Big triangle, horizontal is x plus y, big distance is h. And again, I'm using variables for the instead of the 10 right now because these numbers change as the person's walking. But when I say that though, I have two rates to work with. I want to know, his constant speed, I guess, is the dx dt. I want to solve for dh dt. So this dy dt actually has to come out anyways. So even though we set it up with similar triangles, we are going to talk about how x plus y equals 10. And we're going to have our two rates and two variables now. So this is kind of a bit of a mess for an equation. So we're just going to do some cross multiplying and get 20 equals h times x. And now I have a function that's far easier for me to take the derivative of. So same as our past problems, we match the number of rates to the number of variables. Two rates, two variables. I got a function. I'm going to differentiate using the product rule because it's x times h. And we'll go from there. Derivative of 20 is 0, right? And then derivative of x is 1, derivative of h is dh dt, and we just kind of go through the product rule. So I got to solve for my moment in time now. So my moment in time says I am 3 meters from the wall, which means that my y value is 3. I don't have a y value in my formula. I have an x value in my formula. So I use that information again, and if I'm 3 from the wall, I'm actually 7 from the spotlight. So you kind of go back up to our story like earlier. If this is 3, this is 7, and that's the moment in time that we're talking about. So I'm given my walking speed is 1.2 meters per second, dx dt. My x is 7. Indirectly now, I still got to find my h. So this is where we talk about shrekking the problem, right? Adding another layer. Some of our problems, you're given h. Sometimes you got to solve for h. So go back to what's given to you. You got this formula, 20 equals x times h. If you know x is 7, you can solve for h. And then plug in dx dt, plug in x, and plug in h. And then you solve for the unknown. So you solve for dh dt. And when you see this problem, the answer it's negative, and that's just because your shadow is decreasing in size. So 24/49 or 0.49 meters per second is your answer. So there you go. That's how fast the shadow is decreasing on the wall. I'm sure it's a problem that we were all really concerned about before the day started. Take care.